Hi everyone. So this is another lead code question that we're solving today, and this question is called two-city scheduling. Okay, no, it's not two-city scheduling. Sorry about that. It's actually this one. So it's design underground system. Okay, and this is a medium question. It says an underground railway system is keeping track of customer travel times between different stations. Try using this data to calculate the average time it takes to travel from one station to another. It then says implement the underground system class. Okay, so it gives us a customer with a card ID equal to ID. It checks in at the station, right, which is the station name at time t, and then a customer can only be checked into one place at a time. The second function here, the second void function here is a customer with a card ID equal to ID checks out from the station name at time t. And we have the third one, which is to get the average time. So in this question, it's basically working like a scheduling kind of software, not necessarily scheduling, but like a routing kind of software. So over here, the first thing I did, I used my whiteboard. Let me show you. And so we're going to have a key value pair, which the key is going to be the student ID. The value is going to be the station name, and we're going to have a tuple as our value. So it's going to be the station name and the time checked in. And then for the second function that we're going to be working on, we're going to still store it too. So we're going to store the student ID, and as a tuple, we'll store the time arrived and the station that was arrived at. And to calculate the average time, we're going to calculate the start time, the arrival time, over the number of times people have gone down this particular route. So over here, I actually solved this question, but I'm just going to explain what I did. So I created a map, which was called check-in map, right? And this check-in map, what it does is that it stores the ID as the key and the value as the start station and time. Then we also have a total map, which is basically calculating the time for me. This is here because it'll make it easier for me to calculate the average. And so over here in the check-in function, I just created my hash map, right? I just created my hash map. So wait, it's a hash map or a dictionary? I think I prefer to call it yeah, I think it's a hash map. So I just created, let's see, what kind of question is this? Oh, I just created my hash table. Let's call it that instead. So I created it, and my key is my ID, my value is my station name and the time. Okay. And then after that, I also have my checkout function. So my checkout function also helped me to calculate my total map, which made it easier for me to get my average time. So over here, I have a start time. I have my start and I have my time. Okay, these are the values in my original in my check-in map. Okay, my hash map. So after that, I stored a value called routes, right? And what routes is that it starts from the start station to the end station. And what I'm saying here is that if I don't have a route in my total map, then just initialize it as 0, 0. So if no trip has started, nobody has gone anywhere. It should be 0, 0. But let's say that someone goes somewhere, right? I want to store that time, right? The start time minus the end time. That's to get my total duration. Okay. Then to then get my average time, what I'm doing over here is that I'm getting my total and my count from my total map. Okay. So my total map, what my total map stores that it stores my arrival time and my start time. So I'm getting that total time from my start my I'm getting that total time from my total map and the count too. And so how I'll calculate the average is that I'll divide total by count. Oh, I wasn't sharing my tab. I'm super, super sorry about that. Probably gonna delete this video. So um I this was what I was pointing to, by the way. So we have this section, and to get my total average time, I'm going to gets my total and count from my total map, and then I'll return the total divided by count. So the total time divided by count. Okay. Um, this is what I have for here. It was accepted, so I think it's correct. And this is an O of 1 time complexity because we are using hash maps. Hash maps is very, very efficient in like storing and retrieving data. So yes, thank you so much. I'm still gonna create another video for this to explain it better, but for now, you can use this. Thank you.